If I asked you to solve a maths problem as hard as this, you probably wouldn't get it, at least not at this stage. But if I showed you something like this, you'd probably have a much better go at it. For a lot of students and adults too, maths is just something that's not enjoyable and really hard to get a grasp of. In the end though, it's not actually about how hard a question it is, but how can you learn, understand, and apply maths concepts. Hey guys, welcome back. If you're new here, my name is Archer. I'm a second year medical student, and on this channel, we learn how to learn so that we can focus our time on the people and things that matter more to us. One of the things that I've been consistently asked, and I've been procrastinating this video, is to talk about how I studied maths in year 12 and what I sort of think about the best ways about studying it now. So I regularly tutor maths as well, so I'm gonna go through with you guys. Firstly, what is usually hard about maths, then the Kolb's experiential learning cycle, and then we'll get a little bit more into how do we learn for maths, and then how do we revise for maths. So a lot of people actually say that they're not a maths person. Often there's quite a lot of reasons for this, but most of the time it's a psychological game. This usually comes down to a fixed mindset versus a growth mindset. Someone with a growth mindset would say, oh, I have more to learn with maths. And someone with a fixed mindset would say that they are not a maths person. And here's another psychological concept that comes into play. If you make an assertion or statement about, I am not a maths person, well, the funny thing is that you're probably going to engage in behaviors and emotions that are going to make you more of not a maths person. It's actually just a little subtle thing that can actually have a big impact in terms of how you think about maths. And the funny thing is that the research actually shows, unless you have a medical condition when it comes to learning, well, most people can be pretty good at maths. It's just that they haven't had the right upbringing with it, or they don't want to go through the harder yards to learn more about maths. And sometimes there's good reason for that. So let's talk about Kolb's experiential learning cycle. I think that this is just something that's so important that's not even taught in school. When it comes to learning how to learn, this is one of the most important things to know because this guides how you go about any of your future study sessions. So there's this guy named Kolb, and basically he created a model about how we generally go about learning things and the stages that we have to prioritize. So when it comes to Kolb, the first thing that we talk about is having an experience. This is about trying something new, and this might be a new question type about the new topic that you're learning in maths. Now, after doing the question, the most important thing is to reflect on how you went. There's no point spamming thousands of questions without even checking the answers to see if you were right, obviously. But I just want to stop here because when you reflect on a question, a lot of people just check the answer. That's actually not enough. Even if you got the question right, you should be checking the work solutions if you have them available to see if there was another way that you could have approached the problem as well. Essentially, when you are reflecting, this is where you make all of the improvements and where you learn the most. So whenever you do a practice question, what's the point of it? You're trying to get exposure so that you can see similar questions in your test. Not only that, this should be an opportunity that you should maximize the learning from. So often I'll spend quite a bit of my time actually just going through the answer and seeing if I was thinking in the same way as them or if there was any improvements that I can make next time. What this really means is that I can learn more from doing one question as someone might if they did 10 questions. So this is just another step in terms of building your study efficiency as well. After this, we head on to the abstraction phase. And usually this happens more often than not when you get a question wrong. Because the thing that often happens is sometimes you might get a question wrong and you had quite a lot of confidence that you were going to be right. This is part of this thing called the hypercorrection effect if you haven't yet heard that. But essentially that's the idea that errors made with high confidence actually lead to greater learning as well. But particularly when we come to this, we're now doing abstraction, which is in simple words, just creating another scientific hypothesis for the next time when you try another practice question. This is a huge thing that not everyone prioritizes. And that's why you should take some time to think about how can you do this a little bit more as well. Now, this can even happen if you're getting questions right. You could just have a curious question about, oh, what would happen if I did this? Would this make it easier to do or would this actually make it harder? And then from there, we head to the experimentation phase. This is where we take that hypothesis that we created in the stage before and we actually just go ahead and try it out. This ties in really well with an experience because obviously when you start to experiment, you'll create that new experience and then this whole cycle starts again. This is why often we say practicing with practice questions is a useful thing because you get to do more of this Kolb's experiential cycle, and this becomes a quicker feedback loop, which means you can get more of a response and feedback about how you're going more often. For example, it might be easier to learn how to dribble the ball instead of how to ride a wave, because when you're trying to ride a wave and surf it, you have to wait a while for the next wave to come. So there's a higher iteration of cycles that you can do here. But I really want to talk about this in more detail in just a sec, because higher iterations is not always a good thing, because you might end up doing more iterations than you actually need. So this is a higher order level way of learning and thinking, and it's not necessarily the easiest thing because it is a model, but whenever you go ahead and try and learn things, try and see how you can involve Kolb's cycle. So when it usually comes to maths, I would say that the majority of people are not learning maths in the most effective way. In most classrooms, you'll probably learn maths by seeing your teacher just go through a worked example on the board. And you might pay attention to them and see them writing it down. You might even write it down yourself, write some little notes as well in your textbook. But the thing is, this is actually a very passive way of learning. One of the small techniques that is very, very effective in this case when we're trying to do maths is the generation effect. It's your attempt at trying the question on your own without even knowing how to solve it yet. Trying to use your previous knowledge to solve a completely new question type. And why is this important? This is even more important, not only just because the science backs it up, but when you get a question that you've never seen before in your test, what are you gonna do? This is an uncomfortable scenario that you have to become familiar with if you wanna do extremely well in your maths test or exam. Now, this is the same thing when it comes to practice questions. Let's say that you try a question, you see that you got the answer wrong. Don't just check the work solutions just yet. Spend a little bit more time trying to get to the answer that they had at the end. This is part of Kolb's experiential cycle, and then you can go through that process, and eventually, if you can't get it, then you can take a look at the work solutions and reflect from there. Mistakes are actually a very good thing in the learning process. Now, this is just an example about how applying maths is one of the good ways of learning, but it's not necessarily the best way. Now, when I also say that, I don't mean that you shouldn't do practice questions, you should just use them carefully. So let me explain the issue of practice questions. The whole point of practice questions is that you hopefully see a similar question coming up in your test, but you know that there are always going to be those curveball questions. And what do I mean by that? I mean those questions that you've never ever seen before, and it doesn't matter how many questions that you do, you would have never seen it. So what does that mean? Well, you get tested on your underlying knowledge. There's no practice questions that would have helped with answering that question. And you might think this is unfair by your teacher or like the examination board, but it's still part of the curriculum and you need to be prepared. So what does this actually mean? When it comes to learning maths, you not only need to learn the concepts really deeply, but know how to relate all of them together. No number of practice questions is going to help in this case. And in fact, you know there's always someone in your class who doesn't need to do that many practice questions, but still does better than you. Well, if this is the case, well, they just have a better understanding of the concepts and know them more deeply than you do. So that when they see a question, they're not thinking about what's a similar practice question that I've done before. They just know how to use the concept that's being asked for. So we want to emulate this. And the way that we can do that is not by just having sheer natural talent, but focusing more on learning the concepts. Why is this the way it actually is? Why are we learning this? Why is it important? Why is this purposeful? And how does this relate to the previous things that I've learned before? Often people find maths harder as it comes up to year 11, year 12. And yes, there is a level of difficulty that comes with that, but mostly it's just your foundations. If your foundations of your house are very weak, it doesn't matter how high you build the building, the rest of that building is going to be pretty weak. And this is how we learn as well. The more background knowledge you have, the easier it is to add new knowledge on top. And if anything, that's one of the best study techniques just itself. You need to know more to learn more. Another thing that people quite often discount is the idea of mind mapping when it even comes to maths. People think it's kind of ridiculous, but the whole thing about mind mapping is about relating concepts together. And in fact, maths is one of those subjects where the concepts just relate with each other so much. When you see that question that seems impossible, but then you walk out the test and someone else gets it quite easily and you see like, oh, it was just that. They were able to see that relationship between two pieces of information or concepts earlier and quicker than you were. So by mind mapping, you're able to explicitly try and tackle that and find it earlier. And an often thing that I hear from a lot of people is they say that mind maps are just a really hard thing to do. And that's really just because you use your brain in a way that requires very high order thinking. You have to spatially arrange things and see how these things relate together. And this is only really possible if you know how they do relate together. Of course, drawing a mind map is going to be very difficult if you don't have a proper understanding about how they all link together. Sometimes people ask me for my maths notes. I had no maths notes. It's all about learning and having an arsenal of tools to be able to answer a practice question. And that's what happens in your brain. So let's talk about revising for maths now. So it's coming up to your test or exam now, and you're thinking about how to best prepare. Once you've reached a higher level of mastery, well then really you want to think about creating new problems yourself. This is often for those who are aiming for the highest of highest results when it comes to maths. There's generally not enough practice questions out there to cover everything. And also the issue with practice questions is that it's kind of a game of luck. You're hoping that the quality of practice questions that you have are going to be exactly related to the test that you're going to have. And guess what? More than often than not, you can't really predict that. So it is a game of randomness here. And this is something that you don't want to be doing when you're trying to maximize your time and how you spend it studying as well. So that's just evidence on its own about why you need to understand the concepts and why you need to rely less on practice questions as well. But when it gets to a point where you need to like very much reinforce your skills and get good with some particular weaknesses, and you feel like you're running out of revision material, then the next step is this on this part of this thing called Bloom's taxonomy. I won't mention it this much here, but basically creating new problems for yourself as hard as you can make them to challenge yourself is a very effective way at getting really confidence with particular concepts. I did this all the time in specialist maths. There was hardly ever enough questions and I needed to see if I really understood what was going on, so I gave myself a harder question. That's how you know that if you're going to be safe for particular question types. And you can only really do this if you have a pretty good knowledge about it already. But I also want to talk about these things about bounded notes, cheat sheets, formula sheets, all the sort of stuff that you might create as well to assist you within a test. Having a formula sheet that is filled up with lots of questions, lots of notes, and all this sort of stuff is a really dangerous sign for your upcoming test. It's a good sign that you don't actually know what's going on and you don't actually know the concepts well enough. See, again, it's all about understanding and not just memorizing. If you put down like example practice question types on your formula sheet, you're just hoping and expecting luck yet again for it to just pop up in your test. This does happen sometimes in year 9, year 10, all this sort of stuff when there's some lazy teachers and things like that. But when it comes to year 12, pretty much never. You could have spent that time like actually dealing with the root issue itself, which would have meant that you've been prepared for maybe 10 similar questions instead of just that one specific one that you wrote down. So my cheat sheets were usually quite blank and I even drew like smiley faces and stuff like that just because I had the space. What you really want to be putting on there is just things that need to be purely just rote learn or memorized. So this sometimes happened with some definitions for statistics and things like that, but for things like calculus and vectors, all these other things as well, I basically did not write much at all. Most of the times I actually understood the formula, which meant I subsequently memorized it. But sometimes I'll just make sure that it's on that cheat sheet. Now, I just want to highlight this so much. Spamming practice questions is a lazy way of getting better at maths. You need practice questions. That is a core part of getting better at maths. But only doing practice questions is quite lazy. Now, the best way that our brain actually wants to learn is through multimodal learning. What I mean by this is that you don't want to be only seeing particular concepts and applying it through practice questions. You want to also be creating your own questions about it as well. Like I just mentioned, but also inquiry-based learning questions as well about why is this important? How does this work with that? Why does it work in this particular way? Those things. The more you can get into deeply understanding it, the more that you actually will be prepared. And the other thing as well is like when the curriculum changes or something like that, there's not going to be many practice questions at all for you to rely on. This is pretty much what happens in uni all the time. There are not many practice questions or practice exams that you can rely on. So it's not even just a matter of preparing yourself for the future. You'll actually waste more time spamming through questions if you do that. There's no point redoing a practice test if you've already done your practice test. There's some value in repeating a question that you got wrong a few days later if you don't remember the solution that you just checked up. You lose so much value and learning opportunities if you do a practice test on time and not that focus as well. And if you run out of practice questions, you're still not acing all of the questions you're doing, you haven't done Kolb cycle well enough. And it probably comes back to you not reflecting that much. So this is the most important part. Let's summarize. How do you revise for maths? This is assuming that you've been learning it and going into the details about why does everything work and things like that. Start off with some untimed practice questions. There's no point doing questions timed if you don't know how to do them untimed. The reason is because if your accuracy when you're untimed is maybe like 90%, when you bring speed as a factor, then it's probably going to drop below 90%, probably down to like 70%, and then you move up from there. But your max is only 90% of accuracy. Often this is quite useful if you use an exam guide or something like that. This is when you get the actual opportunity to figure out where your weaknesses are with the content. Then you can take a step back and learn more about that particular concept if you need to. Once you're good with this, then you want to start thinking about timed practice. This is when the practice tests and practice exams that you might have come into play. This should not be the opportunity where you realize that you are not good at something like vectors or calculus, for example. This is where you get a simulation of the whole test experience. This is where you get to test yourself and see how you deal with test exam anxiety, focus, not losing concentration, time management during the test, and how you deal with speed in general. And most importantly, there is this random selection of questions and you get to see how you do with that random set. You get to see here, this is the best representation of how you might perform on the day if you were to do the test now. These are extremely valuable resources. Please don't waste them and use them early. Practice exams and practice tests should be the final part of your revision strategy. Where you start building all your knowledge should be happening when you're doing the untimed questions. When you're doing timed questions, that's to see if you can keep up your accuracy while you're being timed. And that's mostly it. I can go through this in a ton more detail if you guys want me to, and I can get a little bit more into the science. If you want that, please make sure to comment below. This is just a very, very select few techniques when it comes to learning maths. So make sure that you guys like and subscribe if you've learned something, and please let me know if you want to see more. All right, thanks guys for watching, and I'll see you guys in the next one. Bye-bye.